Welcome back. A very good morning, good evening, good afternoon to all my friends and the students who are taking this course. This is the 17th lecture. Each lecture, as you know, is for duration of half an hour, and this is the 4th week we are into, the second class for the 4th week. So, as we were discussing the concept of utility, what is the concept of expected value, what are the different utility functions which you have, how the certainty value is calculated, how you make a decision depending on different decisions are probabilistic. So, we have covered all these things. So, let us continue our discussion and we will basically expand our discussions in a little bit more interesting practical applications from the conceptual point of view, and once that is over we will definitely go and solve few problems. So, to give a brief outline of what things are going to come, we will try to finish up utility analysis in as much as detail as possible, and then start off the concept of precedence diagram. So, by that way we would generally go into the network concepts, and then in between we will solve few problems and also come back to the different ideas how financial concepts are used in order to take decisions related to projects and investments like IRR, then interest rate and all the things. So, consider again A and B are the wealth values. If you remember, I did draw the diagram and explain to you how you can find out the certainty value. Certainty value you are measuring along the y axis and the investment. So, here was A, here was B, and you made a decision, and this was the 45-degree line. So, what I discussed in the last slide of the 16th class, I will just start off the 17th class with a discussion of that slide. So, if you see this red color diagram where I am basically hovering my pen, so based on that the discussion starts. A and B are wealth values, that is the values of W, which is the wealth in rupees, dollars, euros, yens, Deutschmark. Deutschmark is not there existing now, but Canadian dollar, Australian dollar. Also, for our ease of analysis, we consider the utility analysis is W, which is the straight line, 45 degrees line. Form a lottery such that is an outcome of A with probability P. So, you can make it much simple by considering probability and half and half. So, A has a probability of P, this A, and the other outcome B would definitely have a probability of 1 minus P, because the sum of the probability should be 1. Change the values of P and ask the investor how much certain wealth he or she will have in place of the lottery. So, the concept which I discussed was trying to change the value of A and B. You can also do by changing the value of P. So, let us continue as it is written, and it will be absolutely make perfect sense what I discussed in the last class, the 16th one, and what I am discussing in the 17th one, the lecture. Thus, as C varies with P as the probability changes, now the expected value of the lottery which is there in front of you would be A multiplied by the corresponding probability P plus B multiplied by 1 minus B P. A risk averse person will have this value as this. So, if there is equality sign here, it means that I am indifferent. If the value of C is more, it means I am more risk averse, and the person, just 1 minute, a risk averse person will have this. So, it should be technically be greater. Sorry. So, it basically means that if I am risk averse, I will shun or I will shy away from the gamble, and if I want risk, I will basically go towards the gamble and shy away from the certainty value. So, if it is equal, that means the value of the gamble with respect to the C value are exactly equal. Now, there is only one point which you have understood. The value of C is basically technically UC. UC means certainty value when converted into utility is U with the variable as taking the value of c. Now, that is a straight line because the utility function is w, hence the value is c. Similarly, for a, it is ua, which is again back to a, and b where the utility function is ub is equal to b again because the utility function is linear. So, as p values are changed, or as if p values are fixed and a and b values are changed, you plot the values of c. They can be either above the straight line, below the straight line, and based on that you can find out whether it is concave or convex or straight line, and find out whether the marginal rates are increasing at an increasing rate, increasing at a constant rate, increasing at a decreasing rate. Then corresponding to that you can find out a prime, r prime. A is basically absolute risk aversion property and r is relative risk aversion property. So, how would you find the explicit form of the utility function? Suppose you know that it is of the form uw is exponential in nature, which is this function which is there in front of you. You ask the person that given a lottery which has a 50-50 chance of winning, that means you are now tossing a unbiased coin, an unbiased coin. So, the chances are the amount of money is 1 million or 10 lakhs, the other amount is 4 lakhs. In order to buy this lottery, what will that person, he she be willing to pay? If the answer is 4 lakhs, it means that the person is indifferent between the certainty amount of 4 lakhs and the lottery. So, when you are trying to find out, is basically consider you place it in front of the person and you do not know the value of a. Now, here the value of a has to be calculated. Now, if you put this value 10 lakhs and 4 lakhs in the gamble, so correspondingly you will have these values. Let me correct it. It will be 4 lakhs here, 1, 2, 3, 4. So, what, and this is 10 lakhs. So, this value is the utility corresponding to 10 lakhs, this value is the utility corresponding to 4 lakhs, these 0.5, 0.5 are the prior probabilities, and if the certainty value is 4 lakhs, you put it here. So, here 1 is there, it is not written here because certainty value has a probability 1. Based on that you can find out that what is the value of a. You iterate different values, find out the certainty values and equate it to the gamble. So, as you plot it out or basically equate it, you will find out different estimates of a and take the best estimate considering the statistical properties whatever test you are doing, and you can basically find out the value of a. Similarly, you can do for the quadratic utility function, you can do for the log utility function, you can do for the power utility function, and correspondingly to other utility functions which you may also find. So, utility functions has some axioms or the rules. So, the axioms are very conceptually very interesting. So, let me read them and just explain in very simple terms. They would have no consequence on how we solve the problems. Solve the problems mainly utility would be from the point of view of decision tree analysis and general utility as concepts, and then we will be always using those concepts in the areas of project management. So, an investor can always say that whether A is equivalent to B, where A is better than B, and where A is not as good as B, or that means putting it in another way, B is better than A. That means my choices are I am indifferent between A and B, I am inclined to take A, or in the last case I am inclined to take B. So, in case if I prefer A with respect to B, I prefer B with respect to C, then logically I would always prefer A with respect to C. So, this is the axiom, but in general in many of the practical cases it may not be true. Consider x is equal to y, the third axiom, then assume we combine x with certain decision z such that x is with probability p and z with probability 1 minus p. So, there are two outcomes. On the same lines we have the decision z combined with y, and in that case if probability of z is 1 minus p, then the probability of y is p, then you are sure the value or the equivalence between x plus y plus z, that means the decision outcome is equivalent to y plus z, such that you can say what is the outcome by combining x and z is equivalent to combining z with y. For every gamble or every decision which you make or every, say for example, investment which you make in a project, there is a certainty equivalent such that the person would be indifferent with respect to the gamble and the certainty value, which we have already discussed in one or two very simple problems. So, now comparison, we come to the comparison between the mean variance concept and the utility concept. So, let us pause here for 1 minute. If you consider the capital asset pricing model and the linearity of prices and the concept which we discussed. So, it generally means the fact that we are considering in a sense the return distributions are elliptical in nature. Elliptical in nature means they have some properties, I am not going to go into that, but normal distribution is one distribution which I did mention time and again when we were doing the quadratic utility function, that if the returns are normally distributed, then the actual utility function is quadratic and vice versa, because there are some very nice properties about that. So, and mean variance theorem, which was basically the work done by Pining, work done by Markowitz, for which and other work he won the Nobel Prize. So, we will consider the mean variance concept from the point of view investment and the utility function. Consider the utility function as a quadratic, where b is the parameter for the quadratic utility function, and we have 3 assets and the prices are given as in this table. So, A, B, C are given, I find out the returns. So, returns can be found out if you know in simple statistics in finance. So, returns can be, say for example, I invest at time t is equal to I 0. So, this t is just for the notional concept, and then at t is equal to t 1 I get my value. So, consider this value as I 1, this value as I 0. So, returns can be calculated according to this concept I 1 minus I 0 by I 0, this is R, and another one is I 1 by I 0, which is capital R return. So, you can do it according to whatever you consider. So, A, B, C prices are given, based on that I find out the return for A, B, C individually, and the probabilities are given are basically are equal. So, there are 5 outcomes, I am considering 1/5 for each of them. So, this is a distribution is 1/5 means it is a uniform discrete distribution. So, just for the interest of the students who are interested, I just mentioned that. Now, what I do is that I find out the average values of the returns, that means sum the R A values for all the values and divide by the number of outcomes. Similarly, I do for B and C. So, the average returns with the bar is given for A as 1.06, for B as 1.05 and for C as 1.14, which technically means I am getting a extra plus return of 6%, plus return of 5%, plus return of 14%. So, it was on the other side, so it will be less than 1. And similarly, I find out the standard deviation using very simple calculations as prevalent in statistics. I find out the standard deviation for A as 0.025, B as 0.022 and C as 0.052. So, they can be converted into percentage sense also. Now, I consider, say for example, the prices average WA, WB and WC as 114, 119 and 100. So, if riskless interest rate in terms of the total risk. So, if you remember, I did mention R suffix F, which is the risk free interest rate for investing in a government bond or security for which technically we consider there is no risk. So, there is an average return, but conceptually the risk is not there, and we consider this as 0.05. Then using the mean variance analysis. So, what we do is that if you concentrate here this formula, it basically normalizes the return of B with respect to its average value and the standard deviation. Similarly, for B A, we basically normalize the return of A with respect to its average value and standard deviation, and similarly we normalize C with respect to its the average value and its standard deviation. So, the normalization is being done based on a datum whether the return of A, B or C is more or less than RF, which is the risk free interest rate. So, if RB is more than, say for example, RF, it makes sense to invest. So, technically what we would generally do if we are not thinking of risk for the project, we will first basically analyze the returns as the primary motivation based on which we will rank them. Then if you are only considering risk, not the return, least to the maximum value of the risk, and if you are trying to basically combine them and find out the ratios, then we will consider, if you remember, consider the ratio of mean to risk or risk to mean and rank them from respectively from the maximum value to the minimum value, or for the second case from the minimum to the maximum, and take it correspondingly. Now, why RF is coming is because the risk free interest rate is being considered as a data based on which you will basically analyze whether the investment for the project is right. So, if you find out the difference of RB over RF normalized with respect to the standard deviation, which is the dispersion, it is 25%, for A it is 22.4% and C it is 12.3%. Hence, technically for project B, where we will consider as 25% as the return is the highest, hence we will basically allocate our amount of money for the project accordingly. Using quadratic utility function, if you now basically have, so this was done, the first part where I am now marking it as 1 was done based on the fact, anyway let me highlight. So, this part was done based on the fact that the mean variance concept was being used, which was by the Markowitz. Now, in part 2, if you consider this part, what we are doing is that we are considering the quadratic utility function to be true. So, a quadratic utility function is given where B is minus 0.002, and what we do is that based on the prices, here return and standard deviations are not coming into the picture. Based on the prices, we found the utility functions and they come out to be 90.68 for B. So, the B prices are given 119, for A it comes out to be 88.01, for A 114, the weights are not the weights, the wealth is given. For C it is 80.00, again for C it is given as 100. So, based on that, once you rank them, you will find out the quadratic utility functions concept being used, then the utility of B is highest than A and A is better than C. So, you rank them. So, if you compare the first concept being utilized for a ranking and the second concept being utilized for the ranking, generally they match, because due to the underlying assumptions being fundamentally true for both of them. Consider the following with two different sets of outcomes, again coming back to similar type of problems which we started with for discussing utility functions. So, scenarios are given, outcomes for scenario 1, which is 15, 20, 25, 10, 5, and for the next one again the scenarios are 20 till the last one is 30. Now, what we have done here is that we have taken again the wealth is the same type of problem, just a repetition in order to like kickstart our thinking process in a much more positive light. So, W's are given, based on that we find out the utilities, and the probabilities are given. Probabilities are basically simply that you find out the total sum of the scenarios, which is scenario 1 plus scenario 2, and then find out what are the corresponding probabilities. So, for scenario 1 and scenario 2, there are two outcomes, based on that you find out the probabilities, which is given in the last column. Again accordingly we find out the expected value and rank them, if there are more than one projects, and if both of them are same, we then basically go to the risk. If again if risk is same, say for example, so we may be tempted to rank, use the concept of risk to return, return to risk, how good it is, better than the risk free interest rate, and all those things. So, deterministic probabilistic one, we have already considered the diagram. So, I am just again highlighting it. So, the equivalence between them would be true if the overall expected value which you have. So, the overall expected value in this case would be Pi into Wi. So, Pi, how many i's are there? 1, 2, 3, 4. Wi I am considering as the utility. So, in case if the utility is linear, then it is W. In case if it is not linear, then I have to use the utility function as given. So, I basically sum up. In this case, what I am doing is that for each arm, that means the Pi into Wi, I am breaking them into a fair gamble and then trying to find out if the utility concept of the certainty value is equal. So, in this case, what will happen is Bi into Hi plus 0 into 1 minus H1 should be exactly equal to P1 into W1, but again we are considering the B1 and zeros are the corresponding utilities based on which we are doing our calculations. So, if there is some other utility function, we will basically use that utility functions, but multiply it by the corresponding probabilities, which is in this case H1 and another arm has a probability of 1 minus H1. So, generally for the investment processes or the project management concept or investing in projects or making a decisions, people have other criteria of selections also. One of them is the geometric mean return, one is the safety first criteria, third one is the stochastic dominance concept and analysis of terms and characteristics of the return distribution. So, we will consider in detail the first two and just mention about the third and the fourth and then proceed. So, I will try to, as I mentioned as we started this lecture, we will definitely go through one or two very simple problems for these concepts as we proceed with the project management course. So, the geometric mean return distribution means for the selection process we consider the maximum geometric mean such that is the highest probability of reaching or exceeding any given wealth left in the shorter possible time or return being maximum. The highest probability of exceeding any given wealth length over and above the given immediate time. Now, why geometric mean is used? So, if you consider very simple statistics, we know that there are generally there are three type of average measures. So, I am not considering mean, median, mode and the median. I am considering the average characteristics, one is the arithmetic mean, one is the geometric mean, one is the harmonic mean. So, when I am considering the arithmetic mean is just the simple average. So, if I have 10 jam bottles and I want to find out and the weights of all of them are given, I want to find out the average weight. So, I will just sum them up, divide by the number 10, which is the number of jam bottles. If I want to find out the height of a set of students, I add up this height, divide by the number of students. Now, if I want to basically use the concept of harmonic mean, then harmonic mean has a very interesting example which we all know. Consider a car travels from Delhi to Bombay at a certain speed and then comes back and takes certain time, and then it again travels back from Bombay to Delhi at a certain speed and considering a certain time, and you want to find out what is the average speed of the car traveling between Delhi to Bombay and back, then we will try to use the concept of harmonic mean. So, I am not going to give the formula, but just for people who are interested, they can check up any simple class 11 or 12 book or even class 10 book. Now, if you come to the concept of a geometric mean, generally geometric mean are used in financial concepts because interest rates are accordingly calculated. So, here I will try to give the formula because this is of interest for us for this course, and I will, as I mentioned, that for arithmetic mean and for basically the harmonic mean, people can check simple examples, very interesting examples. Now, when you have two interest rate R1 and R2 for year 1 and year 2, and I want to find out what is the interest rate which is being applicable for year 1 and year 2 combined, then I actually I will be using the concept of geometric mean. So, how it is done is like this. Say example, interest rate for year 1 is R suffix 1, interest rate for year 2 only is R suffix 2, and I want to find out what is the interest rate between these 2 years combined. So, if I have year 1 year, year 2 second year, and this is equal to interest rate for 2 years, what I do is that I know R1, I know R2. So, if I need to find out R, and then I just simply put it in this formula and calculate. So, this is the concept of geometric mean averages. So, generally geometric mean returns and averages concept are used in these cases. Consider the IR, this capital R is the, if you remember again just for recollect, and if we remember we had two values I1 minus I0 by I0 and another was I1 by I0. So, this is capital R which we are using here in our calculation. So, capital R suffix I suffix j, where ith possible returns for the jth portfolio or jth investment or jth project is given, and I want to find out the geometric mean averages of that portfolio or a project or a set of conglomeration of activities which are there. So, it is given by, if you notice, 1 plus R suffix 1 j is basically for the first possible return for the jth project multiplied by to the power corresponding to the probability for the first. Similarly, we continue doing it till the last one, which is basically R 1 plus R suffix n comma j for the nth possible return for the jth project multiplied to the power p n suffix n comma j, which is the probability, and minus 1 because you have to find out the percentage. So, based on that I can find out the return on the geometric means concept for the projects and then rank them accordingly. So, this p I suffix I j is the probability the ith income for the jth portfolio, then choose the maximum value for the geometric mean values and then rank them accordingly. Consider we have the following combinations of assets. A, B, C are in the following figures as they are given in this table. Ratios are for 1, it is given as 20, 20, 60, sum is 1. For the second one it is 1/3, 1/3, 1/3. For the third one it is 25%, 25% and 50%. And the returns for A, B, C are given as 10, 20, 30, it can be in percentage terms, it can be in ratio terms, whatever it is, I am just giving the values. So, if I want to find out the return for portfolio 1, portfolio 2, portfolio 3 for scenario 1, 2, 3, so with the suffixes it will basically make sense. So, where my finger is, P means the portfolio, comma 1 means the case. So, in this case for the first one it will be 1 plus 0.1 because there is the return to the power 20. So, this 20 is coming. The second one will be 1 plus 0.2 is the return to the power 20, and the third one is 1 plus 0.3 to the power 60 minus 1, it comes out to be 0.237, which is 23.7 percentage. For the second one, if we do again the calculation, 10, 20, 30 remains same, 10, 20, 30, and if I want to find out the probabilities are given as 1/3, 1/3, 1/3. So, here the probabilities are 1/3, 1/3, 1/3 minus 1 gives you a return of 19.7%. And if I go for the third one, again returns are 10, 20, 30, probabilities are 25, 25, 50, and I put them on to the power as given here, I find out it as 22.2%. So, if I again look at in this diagram, choice is scenario 1 considering the concept of geometric mean return. You could have done is using the utility analysis, you could have done using the concept of mean variance, concept of the portfolios for projects. So, this is just an example to give you that how different concepts can be utilized to rank projects, rank decisions accordingly. So, with this I will end the 17th class, and then again let's finish the last portion of the utility analysis and the concepts in the 18th, and most probably we may go into the 19th one, but I will try to finish in the 18th one, so as that we can cover a whole lot of new concepts which are exciting for the students, and I am sure they are going to benefit if they study. Again, I would urge, I am bringing this point again, please study the slides, understand the concept, write to the forum, get in touch with us, the TAs and the instructor, and please read the books. There are a lot of books which are available, and the whole set of books which are given, they are also available in PDF format in the net. You can definitely search the net or else get the hard copies of the book from the library, and I am sure if you understand them, read it, do the problems, many of the concepts, interesting concepts, actual practical implementable concepts of the project management would definitely be clear. Thank you very much. Have a nice day.